that back to me, now is not the right time to do it, right? Because I can't change somebody's grade. Do I what? Do I have what? For which? Oh, yeah, literally right here. That's the one we're doing today, and then this was here. This is front and back.
I think I dropped one of my things in the hallway. I already have my resources thing out and my plan was put out. Can I go check out quick?
If you need a resource, that's all you're asking about.
No,
Yep, sure.
I dropped
go.
one of my things.
You're sure. Yeah. I just thought you wanted another resource page. Yo! I got some people that I bet didn't fill in their plan book yet. If that's you, get it out. Fix it.
What are you doing by mini mastery?
We will be having another mastery before Discovery Day. It is not the end of the chapter. So, in the middle of the chapter, I call them mini masteries. If you want to be real technical, it's the difference between a formative assessment and a summative assessment. This would be called a formative assessment.
Yay.
Formative is as you're going. Summative means after you put everything together. Sum, like the sum of things. Yes. It's not a math joke. It's literally what it's called. Formative assessment is while you're still forming the knowledge. Summative, you should have already acquired all the knowledge.
Is this quarter 2 or
Quarter 2. Everything's quarter 2 now. So, good reminder. Discovery Day deadline, Mastery deadline is Wednesday. But all of the new grades are quarter 2 grades. So if you have something in math, that's a quarter 1 grade that needs taken care of. If we do it this week, it will be a quarter 2 grade that will eventually need taken care of. What's up? Did you lose your resource page last week?
We already have it. Okay.
You already have it. So you need out the resource page that looks like this on the back. You need a copy? I can't hear you. What's up? Just to put it out there, I am not trying to make a fashion statement. I think I may have fractured my wrist. I need to go get an x-ray. This is a brace. It is not just me trying to be cool. I know it looks like it's like a bracelet sort of thing because it like it's red and black and kind of looks cool. But my wrist hurts a lot. A lot. I went and picked up about 50 pieces of lumber with a friend who was building a house, and then I went and helped my brother move. So we were moving couches and beds and heavy stuff. Tomorrow. I'm going to write it on that board too. The homework that Matt turs today is it's 316 today. You can get the rest of the week later, but we got to dive into the lesson. We got a lot to do, and we've already spent a few minutes not doing math yet. So I got a challenge for you. I have another silent board game. So do not talk. You'll ruin it for people. Do not talk. Here's your challenge to see if you can figure out the relationship here. Yep, graph paper. Always graph paper. Always gotta have graph paper. We always have graph paper every single day. I would invite you to get on that with us. We should have graph paper out, so if you don't, try to make that happen like here in the next, 30 seconds.
Man, this is absolutely so flag to be doing what you need to do.
Let's go ahead and say we'll either check homework at the end of class today, or we'll just do a bunch of homework checking tomorrow. An input of 1.5 generates an output of 9. These are the 3 main ones that matter that you might want to write down in your paper. An input of 1.5 generates an output of 9. An input of -2 generates an output of -5. And an input of 3 generates an output of 15. Remember, no talking. If you think you got it, you can raise your hand and tell us an input and output, and we will check your output and see if it is correct. You can look at the bottom and see something happens to the x with multiplication, and something happens to the x with addition. Now, could I turn that addition into subtraction? Yeah, use a negative number. Could I turn that multiplication into division? Yeah, use a fraction. Right? So all because it shows multiplication and addition does not mean that we can't do anything else. Nevin, you want to try one? Negative 1, you think spits out negative 1? Colin? Negative 37. Ooh. So am I, don't worry. Patrick?
Would negative 1.5 be negative 3?
Negative 3? Aiden? Well, I was the one doing it. Sorry, that was me. Doing the ooh. Aiden? Russell? Negative 7? Or whatever you want. Would 5 be 23? It is. Alright, hold on. Let's not take any more guesses for a second. Let's let people think. Yeah, we're not doing very well with the silent part of this, but that's okay. I like that you guys are so excited you want to talk to each other. I don't know it either. Like, I have not figured this out yet.
It's simple. You put in the number.
And then you get out a number, right?
What number is his guess, and then you got
Right?
right.
So, hashtag. Oh. He said just put in a number.
Hashtag relatable.
Any and every number, so it would.
Ah. Brenda, what do you think?
It's negative 7, negative 25.
Hey. For y to be the right thing, x has to be the input. I heard somebody say, why does y not work? Like even trying to trick it. Jake?
Would negative 9 be negative 24?
Actually, he said 24. But that doesn't work either. Well, yeah, that's what I typed. All right, let's just do. We only got 3 left. So anybody, what do you think negative 9 generates? Negative 33. Ooh. Negative 4. What does that generate? Negative 15. Oh, 13. Ah.
31.
I forget who the first person. Who was the first person who gave me one here? Nevin. Nevin, what do you think the relationship is? 4 times an x plus 3 more. How'd you figure that out from the beginning? Hey, why are we talking? Hey, Nevin's going to tell us how he figured this out, because for those of us that are struggling for wait, how? What the heck? Nevin?
What I really did was I didn't focus on the negatives first. Because usually those are just complicated things
So we had the 3. Did we have another positive at the beginning?
Yes, 1.5.
Ah.
So first I did the 315 because it just seemed like they had like really nice numbers there.
Yeah, that would be times 5, right?
Yes, that didn't work for anything else.
That doesn't work.
Dumb. I killed it.
Killed it. I like it. I'm giggling.
So I tried 3 times 4. Like, what would that do?
And that then got you.
Plus 3 is that. So I tried it on something else, 1.5, which got me 1.5 times 4 equals 6 plus 3 is 9, so that would work there. Then I finally tried it with -2 to -5, it worked there, so it was like, I got it.
Yeah. Nice. All right, one more, then we'll dive into the lesson.
Wow, you guys actually have brains that work.
All right, remember this is called a silent board game. So, like, I'm the teacher, so I get to talk. If I look just at this, I might say -1. But then I have to kill that idea when I go here and I realize -1 doesn't work. Right, so this is the thought process Nevin was saying, was like, well, this could work for this XY, but then it doesn't for that one. Here, -5, or, sorry, make it negative. Ooh, wait a minute. Positive 30 becomes negative 35. -6 becomes positive 1.
But then there's -2 and
And -2 goes to -3. Interesting.
Would you guys stop talking, please? Josh, shush.
Can I multiply with a negative? I think somebody's like, well, yeah. I don't have a hint. I mean, Max, are you? I don't even know if you're correct or not, but are you able to give us a hint or ask us a question? Ooh, that's a big hint. That's why it's not up here. That's why 0, because that's a really big hint, and we know what 0 is.
Can I just answer one?
Yeah. Do you just want to? Let's do like one of the weird ones. Do the half or the fourth.
Never mind.
Well, write it down. You got it.
I don't know how I would do that. I need it as a decimal or as a whole.
Okay, well this is 0.5.
That's 0.5?
Yeah.
Oh.
You know a half is 0.5.
-5.5.
Negative 5.5. What? Flex. Max is just like, oh, well, since it's 0.5, duh.
And I think
What
that
the heck,
ruins
Max?
for everyone because it's kind of obvious now. No, I don't got it.
No, I don't got it.
Kind of obvious.
I used all my brain power on that safe room, alright?
Hold on, let's see if another one. I don't know what this is yet. Colin, what do you got? Negative 5.25. 60 seconds. 60 seconds. Just think. Stop talking. If you know it, stop talking. Oh. Well, I did now. I think. Guys, if you want to watch something kind of funny, go watch my Math 2 classes, although half of them don't get recorded because there's only 3 of those kids and they're here every day. I literally teach that class like I don't know anything, and like I'm having to learn it all with them. It is the most fun that I have like ever. I love learning with you guys. So hold on, Max, walk us through how you figured this out. Or well, hold on. Do you guys want some more outputs? I guess. All right, give me some new people. We'll go. Anybody that wants to shout it out, actually. What's the output for -1? Ooh, 6? -4? Ah, -4. Lily, what do you mean you have one? What? This outputs to 7? Correct. So wait, hold on. What's the first thing? Don't tell me like the jump to the answer. But what's the first thing that gets your attention here?
The 30 and 35.
Amelia?
How the negative turns to positive, and but also positive stay positive.
The positive input became a negative output,
Wait, no positive.
but a negative stayed negative. And wait, negative became positive. Positive became negative. Positive. So it looks like we're flipping positive negative. Max, since you were the first one that helped us out here.
If you want me to explain -2, I can just easily do.
What's happened with why is this special?
Okay, so I'm just gonna tell you y equals. Wait, that's not how I wrote it. I wrote it x plus 5 in parentheses, and then times -1.
That's what I did.
But wait, if we distribute the negative.
I don't know. That's just.
No, you're right. This is what I'm trying to say. You're right. Because this is the opposite of x and a -5. Now think about it in your head. Hang on just a second. How did 30 become -35? It became the opposite of what it was. So now -30. Take away 5, -35. However, when 2 becomes the opposite of what it is, -2, it becomes +2, but then it's close enough to 0, -5 puts it back in the negatives. So the negative x is happening, but then it's -5. Brenda?
What I wrote was y equals -1 times x plus -5. And what I do to help me figure
Absolutely.
that out usually is on my paper I write the format of the rule and then lines where their blanks is.
And then what?
Oh, lines where the blanks are, so it can fill them in along the way.
Okay. So last week we started formalizing this idea of there being some relationship y equals mx plus b, and y'all got very frustrated with me for a few minutes, which I sometimes like when I do that too, because they're like, what the heck is this? And I'm like, yeah, that's why I have a job. Woo! Because I like money, and having a job gets me money. So
Money is really nice.
money is nice. It helps me live. Getting an X-ray is probably going to cost me some money. So we started looking at stuff like this, right? So I want you and your team to check out these 3 graphs and these 3 questions corresponding to the graphs. Chat with each other about these. Parabola. Not a single bola. We got a parabola. And clap, whatever, because I can't clap. I will, if you want to see your math teacher cry, no. I see how it is. Spencer, what are the coordinates of A in A? Yeah, Spencer. So it's, I think there's only, like, this A. What are the coordinates of it? Hey, why is everyone who's not Spencer talking when I've said Spencer's name 3 times to direct the question to him? Because I'm using random cards. Please quit being rude. You're at school. Spencer. Ooh. Anyone have an argument against it being 2-2? Gus?
Because graph B is a little bit lower.
Well, you are absolutely correct that graph B is lower, and the people saying that graph B has nothing to do with it are also absolutely correct. So graph B is totally a separate situation.
I disagree because it can be like there's
Starts with an S, the word you're trying to remember. Starts with an SC. Brenda, you had your hand up too, right?
I don't know how to say it, but like it makes sense in my head.
Okay, Brenda, do you know how to say it?
Give me 1 minute.
I'm going to move on to Aiden while I give you that 1 minute. Aiden?
You can't necessarily tell because it doesn't show the scale.
There's no scale! We don't know what anything is right here because there's no scale. So, guys, this is my warning to you. When we are making graphs, if your graph does not have any numbers anywhere, sorry to use this word, but it's kind of garbage. Like, it doesn't say anything. It's like, it's why make a thing that doesn't have any numbers on it? Nobody knows what you're talking about if there are no numbers there. We don't know what the heck this is. We don't know. We don't know where A is. It could be 100. But to those of you that think that the spacing of this needs to compare to the spacing of this, it does not. We can do whatever we want. We can make the X's go 1 box at a time, and we can make the Y's go 10 boxes. Like if we're making it on graph paper, you can do whatever you want as long as you are consistent. Brenda?
Because it also, you could have broken the graph.
Yeah, and then we would have seen a broken graph symbol, like the lightning bolt. But yeah, the graph could be broken, especially because we don't know any numbers. We don't know that it's not broken. We hope it's not. Here's the problem. We don't know anything because this graph is not complete. So all we know is somebody got halfway through making a graph. Grant, what about on B? Where will the line be when X is 5? Or wait, we don't have Grant here today, do we?
No, we do.
Oh. Sorry, I thought I said your name. Grant, when X is 5. Wait, when X is 5. I don't see it. Oh, yeah. No.
You tell him, Grant.
Wait, can we? You got to guess? I mean, I can move on to the next person, but you got to guess?
I'm guessing y equals -2.
So, do we have do we have X equals 5 here?
Yeah.
Yes, because unlike in A, this is labeled, and we know 1, 2, 3, 4, so we know 5 has to go there because the graph has to stay consistent. So then we know our scale and our y-axis, and if we trace a little line, that's where 5 would probably be. That's probably where where it would hit. Yeah, probably about -2. You're right about there. Maddie, what about in C? What is T when K equals 1? T and K?
Time and kinetic energy.
So wait, Maddie, what did your team say about what is T when K is 1?
You only got A.
All right, so I'm going to give your team another 30 seconds or a minute. What if I
The parabola. You're doing that to us? Okay.
What if I tell you T is your X and K is your Y? Talk with your team. Could I what? All right, now wait a minute. Hold on. Lily wants to complain, and I'm going to let her complain to the whole class. So Lily said, like, I'm going to add some words here, but she said, like, you evil darn, I don't know. She said, why did you put K here? You'd be a lot nicer if I had put K, but I didn't, because I'm a jerk kind of sometimes. Lily, why is it annoying that I put K up there? If you guys want to come to the board, I just walk away. I'm fine with that.
He was. Wait.
I know why you're complaining too.
Well, first of all, because I've had a bad day, and second of all,
I had a bad day.
I had a thought, but now it seems stupid, and it's even stupider because I can't remember what my thought was. So basically,
Your thought's 100% right. I know what your thought is.
Yeah. So, you see K right here? You see how it's really hard to determine where 1 is? Because we don't have a ruler, and this graph isn't on paper, even if we did have a ruler.
And beyond all that, everything you said is right.
This has a really nice 1 right here, and how T doesn't line up, which is so annoying, but it's less annoying because we can be like, it's
Oh.
right there.
Wait, but what about right here then? Isn't K also 1 there?
That's just where 2 is right now, because this is K.
Oh, okay. So, but like here. Here, let me see this. I got a question. At what time will this roll of tape? Right, I just wanted to confirm that gravity's working right now. Right, I just slow confirmation. What if I dropped it and it flew up? That'd be freaky. All right. At what time will the height of this tape be 6 feet? Right, I'm about 6 feet tall. So if I throw it, the height was 6 feet on its way up and 6 feet on its way down. So if you remember the last mastery we took, I gave you this formula. I really want to write with a pen.
Oh, well, that formula. A equals time minus 3 or whatever.
Oh, I remember that problem. I got it right. I got 650. That's how amazing I am.
This. You could write this down if you want. You don't have to. This is not just a single bola. It's a parabola. No, that was a bad joke. This is a parabola. Pronounced correctly. It's parabola. It's not pronounced parabola. That's the joke. And this is something that we all rely on a lot. You got a guess, Gus? You with me? Because it looks like you and Max are off task. That is gravity. That -16. This second per second, which is really crazy. It is actually an accelerating force. Right? So, for what you talked about gravity, hopefully you know gravity pulls us down. But if you drop something out of a plane, off a building, whatever, it starts at a speed, but it actually gets faster.
Because more forces coming.
Because it keeps pulling and keeps pulling and keeps pulling until you reach
Speed!
So this piece of paper, right? What is happening that it is not falling like immediately to the ground? Brenda? Okay. Malachi? Yeah. We already had it shouted out, but not by a hand raise. Lily. Air resistance. So there's a thing called terminal velocity.
Whoa.
And that is what stops things. Get out that resource page you had and look at these. And come to my desk. You get a new seat now. I'm a man of my word, Max. I told you last week. If you don't correct this behavior, you're getting a new seat.
Yay, comfy chair.
Oh, no. You don't get the comfy chair. This is not a reward. Nah, we'll just do the exact same. Sorry, guys. We're at the point in the year where us teachers we got jobs to do, right? And we're going to do it the best way possible no matter what. Sometimes we got to control your behavior to do so. We said last week that the M had a name, right? What was the M called? No, not even close.
Maximum?
No.
Minimum?
No.
No, it was something really weird.
Slope.
What?
Write this reminder on your graph paper if you need.
We talked about
I know, we were real confused.
rise over run.
The B, if we have something added or subtracted on, is the y-intercept. Write this down. The slope. Yeah, either on your graph paper or the resource page. I don't care which. If you want to put it at the top of the resource page, there is some space. But you need it written down somewhere. Otherwise, you're only going to stay in your land of confusion. The slope is, new symbol time, delta y over delta x, which is a fancy, not even fancy, it's just the symbol meaning change. Change happened. A lot of times in science, we use delta T for temperature. So when we look at these, I should really just slide this down. We can identify what is the y-intercept, what is the slope, and then we can actually graph it. We can put it on a graph. So go ahead and try it on the back of that resource page. You've got your x and y axes. But what's missing from those axes?
Numbers.
Any numbers. So we need to give ourselves a scale and try to graph these. What's up? No, because they're both just like part of a label. So it's saying what was your change vertically, what was your change horizontally. So I agree with what you're saying with like a numerator and denominator cancel each other out. They're not numbers. It's just part of like it's showing us what it is. So you just put x over y or y over x. It looks like you're just looking at a point. We don't want to look at a point. We want to look between 2 points. What's the change? So that's what the time means. Change. Max. I need you making better choices. We're graphing these things. What did I just ask you to do? Add labeling on your axes so we know what the scale is. So if we scale by ones, right, then I'm going to say this is 1, this is 2, 3, 4, 5. I don't have to label every single box. Did I say you have to label every single tick mark? And guys, the example we just looked at, we just talked about this. Because we see a 2 and a 4, we know what everything else is. Right? We do not have to label every single thing. Sorry if elementary teachers made you. Sometimes they are silly. So if we write down y equals negative x plus 1, that tells us our y-intercept, where we hit the y-axis, is at a positive 1. And the slope tells us how to move. So, if this was negative 1, right, because negative x is really negative 1, and I can make negative 1 into a fraction by making it negative 1 over positive 1. Ooh, careful. This is vertical above horizontal.
Oh, so you go down 1 and up and
Down 1 to the right 1. So down 1 to the right 1, next point. Down 1 to the right 1, next point. Down 1, right 1, next point. And once we've got a few, you can just connect them. And guys, be smart about this when you go to draw your line. See how these go through intersections? Pick one of those intersections kind of far away to make sure that your drawing looks decent. And then up here, find an intersection kind of far away to make sure it looks decent. And that would be our line, y equals negative x plus 1. Yes, Lily. I can, but we are sadly a minute away from the end of class. So this is exactly what we're going to pick up tomorrow. So go ahead and try to graph these real quick. You've got a minute left. Wait a minute. That graph of C looks different than the other ones. Oh no. Uh-oh. That's not y equals mx plus b form, right? Because it doesn't have a number in front of the x. It has a number after the x. Uh-oh, looks like I got more to teach you tomorrow. I'll see you guys tomorrow. Max, your line is completely wrong. Your line is totally